You might be tempted to look at the release of Gemini 3 Pro and dismiss it as standard industry progression. You might look at the version number and think, well, it's just another iteration, isn't it? But that will be a catastrophic error in judgment. You have to look deeper than the surface level. You have to understand what is actually shifting in the bedrock of the technology. Because what Google has announced isn't just a faster chatbot, it is the emergence of the machine that is capable of genuine deliberation. And that is no small thing. We need to dissect the architecture of Gemini 3 Pro. The fundamental innovation here, the thing you need to pay attention to, is the concept of dynamic thinking. In the past, you were dealing with a system that was essentially reflexive. You gave it a prompt and it immediately predicted the next token. It was impulsive, but with Gemini 3, they have introduced a parameter called thinking level. When you set this parameter to high, you are effectively granting the machine the permission to hesitate, and you want it to hesitate. When the model engages this mode, it doesn't just speak, it generates thousands of internal talks tokens. It enters a recursive loop where it formulates an hypothesis, critique that hypothesis, check its own logic against the facts, and then, and only then, it manifests an answer. It is separating the signal from the noise before it engages with you. And the proof of this competency is in the hierarchy of the benchmarks. We are seeing state-of-the-art performance of Math 500 and the GPQA Diamond. These are not trivial tests. They represent expert-level reasoning capability. But this competence places a burden of responsibility on you, the developer. You cannot use this technology carelessly. The documentation is explicitly clear on this, and you need to listen. You must keep the temperature at 1.0. There is a temptation in the engineering mind to impose order to lower temperature, to make the model deterministic and safe. But if you do that here, you are making a fatal mistake. The reasoning process, that internal dialogue, requires entropy. It requires a certain amount of chaos to function creatively. If you lower that temperature, you strangle the thinking process. You lobotomize the model. You have to be willing to tolerate that necessary degree of uncertainty to get the truth. And then there is the matter of the talk signature. When the model thinks, it produces a hidden, encrypted chain of reasoning. It's a record of how it arrived at its conclusion. Now, if you are building a multi-turn application where you are conversing with the model, refining an idea, you are technically obligated to preserve that signature. You have to catch it from the API response and pass it back in the next turn. If you fail to do this, if you are lazy with your validation, you sever the connection between the intent and the action. The model develops amnesia. It forgets why it made the decision it made. It is your responsibility to maintain the continuity of that reasoning. Now, we have to talk about the environment in which this happened. We have to talk about this new Google Antigravity and this concept of vibe coding. Vibe coding is a somewhat frivolous term, I'll admit, but the underlying reality is profound. It represents the dissolution of the tyranny of syntax. You are no longer required to speak the machine's language with perfect precision. You can provide the intent, the vibe, the gestalt of the application, and the model has the agency to bridge the gap between your abstract desire and the concrete code required to build it. And within the anti-gravity platform, this agency becomes literal. You are deploying fleets of agents that possess client-side bash tools. Think about the gravity of that for a second. You are not just asking the AI to write code. You are giving it the keys to your terminal. You are allowing it to navigate your file system. It can write a script, execute it, witness the error in the console, confront the anomaly, and then autonomously rewrite the code to fix it. It is a feedback loop of self-correction. It confronts the unknown and establishes order. So you have a system that thinks before it speaks. You have a system that understands intent over syntax. And you have a system that can act in the real world and correct its own mistakes. The question you have to ask yourself is this: if the machine is now competent enough to handle the how, to manage the implementation, the logic, and the repair, are you disciplined enough to articulate the why? Because if you don't have a purpose, the tool is useless. Let that sink in for a minute. And if you want to help me figure out where this is going, subscribe.